1 and type 2. Now we are going to start type 3. Type 3 questions, whatever I have given to you earlier, that questions I have replaced with the questions of textbook and the previous year board questions. So you need to solve the new set of the questions. Okay, so out of that assignment, some questions which are based upon certain methods, I have taken some sample questions for you. Remaining questions you try, and then afterwards you let me know whether you are able to solve the questions or not. So let us see the first question. First question we have given here, integration of 3x square dx upon 1 plus x to the power 6. The same question I have written here, but once again, only one change I have done here. The x to the power 6, I have split it into two parts. Power is inside I have taken 3 and outside it is 2. Because x cube I am going to take as t after that, and x cube if I take t, then if I differentiate with respect to x over here, then the differentiation of x cube is becoming 3x square, as you know. And secondly, the differentiation of t will be dt upon dx. Okay, now if we move further, then 3 I have taken in the place of denominator of dt, and dx I have transferred onto the left hand side. You can write down this equation also, and if you keep it 3x square as it is and dx you transfer onto that side, then equation will become like this: 3x square dx is equal to dt. Okay, because in the question already we are getting 3x square dx, so it will be better we can keep 3 onto the same side and only value of dt we can find out. Now you see I have written in this format, x square dx value I keep it here 3 dt, and 1 upon 3 which I was getting along with dt, that 1 upon 3 I am keeping outside. Okay, so 3 and 3 will be cancelled. If you use this equation, then 3 will not come, only you will write down dt over here. And now if I replace the value in the place of denominator here, so 1 I am replacing as it is, 1 is as it is, and in place of x cube I am putting as t, and the whole power is t over there, so it is becoming as now t square. Now 1 I can write down, this 1 I can write down as 1 square, so dt upon 1 square plus t square. If you look at properly, this integration is in the form dx upon x square plus a square. The formula is 1 upon a tan inverse x upon a. Here the value of a, I can say 1 is there. So if I apply this formula, then 1 upon a will be equal to 1 upon 1, because value of a is 1. Tan inverse x upon a, my x is who here? T, and upon a will be equal to 1 plus unknown constant. In the next step, 1 upon 1 we can leave it, and tan inverse t, value of t I am keeping as x cube. So we can say this will be the final answer of my question. Similarly, let us see the next question. Next question is actually question number 3rd. Question number 2 I have skipped for you. You can try it later. It is in the same way you can solve as we have done question number 1. Now let us see the question number 3rd. We have given that integration of dx upon under root of 2 minus x whole power 2 plus 1. Okay, 2 minus x I am supposing as t over here. Okay, for some time take it as t. When we will differentiate 2 will become 0. Differentiation of x, you know that it is 1, and again differentiation of t with respect to x will become dt upon dx. Now dx I transferred there, minus sign I can put on dt, so dx value is coming here minus dt. Now replace the value in the main integration. So in place of dx, as you can see here, dx I replace by minus of dt. In place of 2 minus x I am keeping here t, whole power 2 is as it is, and 1 I am writing as 1 square. Now my integration will be in this particular form. Compare the integration. Integration is now in this form. Okay, compare the integration. Dt upon under root of t square plus 1 square, and the formula is dx upon under root of x square plus a square. Formula is log of mod of x plus under root of x square plus a square. So our x is actually t and our a is 1. So I put up the value here. As you can see, value of x I am keeping t here, both the places, and value of a I am keeping as 1. 1 square is becoming 1. Now finally the value of t I am keeping, value of t is 2 minus x. Okay, see here, earlier t was coming, I am keeping the value of t is 2 minus x. Again here, value of t I am keeping 2 minus x the whole power 2 plus 1. One change I am doing here because it is expected in the question. I am keeping here log 1. Log 1 is actually equal to 0. As you can see, I have written here. Log 1 is 0. So 0 if I am writing in front of log, that doesn't matter, and 0 I can put up here as log 1. And by writing in this manner, log 1 minus log, this whole value is coming in this particular format. See, here formula I wrote, log m minus log n is equal to log m upon n. What is m here? That is 1. And n is this whole value, mod of 2 minus x and the other things. Okay, so if I apply this formula here, log of m minus log n is equal to log of m upon n. So I can write down log m upon n. This whole value is n. One more thing I have done here, the a minus b whole square formula I applied on this bracket, and I have opened the bracket with the help of this formula. And later 4 and 1 we have added, so it will become the integration x square minus 4x plus 5. Okay, I hope it is clear to you. Now let us see the next question. Question number 3rd. Third question, you can see integration dx upon under root of 9 minus 25x square. Okay, in this question also we can apply any of the special formula listed given in the list of the integration. So that formula we can apply. But one new thing we shall learn in this question. Remember, whichever the formulas are given in the list of the integrations formulae, in that the coefficient of x square should be always 1. Here the coefficient of x square is given 25. So first of all we shall take 25 common. Whenever you are taking 25 common, in the coefficient of x square will become 1, but whichever the term do not have the 25 as a multiple, that term will be divided by 25. Okay, because if you multiply again, 25 and 25 will be cancelled, and again originally you will get 9, and then 25 will multiply into the x square also. Now 25 I am taking outside the root. You know that 25 will come outside the root, it will become 5. So we can say the whole fraction will become 1 upon 5 because 5 is coming at the place of denominator. And 9 upon 25, as you can see here, 9 upon 25 I am writing as 3 upon 5 whole power 2. And then x square will be as it is. Now this particular integration, if you see, it is in this form. Here 3 upon 5 will play a role of a, and x is my variable, that is coming as it is. So dx upon under root of x a square minus x square is equal to sine inverse x upon a. So see, 1 upon 5 it was coming as it is. Okay, sine inverse, then according to the formula who is coming here, x upon a. So x is x only, but a is 3 upon 5. Now 3 upon 5 will go at the place of numerator, it will become 5 upon 3. So 5 will multiply finally with x, and then 3 will occupy the place of denominator, and this is your answer. Similarly, let us see the next question. Question number 5. Question number 5 is very similar to the question number 1, but again I have taken this similar kind of question to make you clear about the method once again. Integration of 3x upon 1 plus 2x power 4. There are two problems. Earlier you see x to the power 6, I have written x cube whole power 2 in the question number 1. Same way, x to the power 4 I will write down x square whole power 2, as you can see here. Okay, so that is the routine thing we have done earlier, we know. But one more thing we have learned from the previous question, the coefficient of x square or the higher power of x should not be other than 1. So here 2 first of all we shall take common. So 2 I have taken common. Since 1 do not have the multiple of 2, so 1 upon 2 will come, and now this coefficient will become 1. This 2 I have taken outside the integration, so it is 1 upon 2 now. Numerator will be as it is, and the power 4 I have split into the form 2 into 2. Now I am supposing x square is equal to t. X square, if I take t, derivative of x square will be equal to 2x, okay, and derivative of t will be dt upon dx. If I do the shuffling of the terms, then dx will be transferred here and 2 will come in the upon of dt. So you will get this equation. So now in place of x dx, I am keeping as half of dt. So half I am keeping out and dt will be at the place of numerator. 3 upon 2 will be coming from the earlier steps. You can see 3 was here and 2 was in the denominator. So 3 upon 2 I have taken outside over here. Now dt upon 1 plus, because 1 upon 2 plus, and in place of x square, here you can see x square I am keeping t and their whole power is again 2. So this will be t to the power 2. Okay, now here 1 upon 2, because formulas are applicable in such a way, along with the square of the variable we require the square of the constant term also, but 1 upon 2 is not a perfect square. Last time 9 upon 25 was a perfect square. We can write down 3 upon 5 whole power 2, but 1 upon 2 we cannot write down. So 1 upon 2 we can write down as 1 upon root 2 whole power 2, because square and square root will be cancelled and again you will get the same term. So we can say here the value of a will be equal to 1 upon root 2 and the value of variable means x is equal to t. Now you can compare this formula with our term. Then we can apply 1 upon a is equal to tan inverse x upon a. Now I am keeping the value in the formula. 1 upon a, see in the formula you please look. So 1 upon a I am keeping as 1 upon root 2, tan inverse variable I am keeping here t, and upon again 1 upon a means 1 upon root 2. Now 1 upon root 2, this 1 upon root 2 will go at the place of numerator, so it will become root 2 upon 1. One change I have done here, 4 I am writing as 2 into root 2 into root 2. Root 2 into root 2 2 and 2 into 2 will become again 4. So it will remain 4 only, but if I am writing in this manner, 1 root 2 which is common, that could be cancelled. Again this 1 upon root 2 is becoming root 2 upon 1 and value of t I am keeping as x square. So this will become as 3 upon 2 root 2 tan inverse root 2 into x square plus c. Let us see the next question. Now look at the next question. The next question you can see it is given that integration of x minus 1 upon under root of x square minus 1. As you have seen the previous question, normally we have taken the term of denominator as t, so we got the terms of numerator along with dx as dt. But here numerator is given as an addition and subtraction of the two other terms. Okay, so we cannot solve this question in the exactly same manner as we did the previous question. So what I have done, I have split my question into two parts. First part is the first term of numerator upon denominator. This is my I1. Similarly, the second part will be the second term of numerator upon denominator. This is my I2. I will separately find out the value of I1 and I2 and then I will put in the main equation and I will get the whole solution. Let's see how we can find out the value of I1. First of all, I1 is x dx upon under root of x square minus 1. X square minus 1 I am taking as here t. Okay, remember x square minus 1 whole term I am taking as t. Differentiation of x square will become 2x and differentiation of 1 is becoming 0. Since you are aware that the differentiation of constant term is becoming 0, so I am leaving that part. And again differentiation of t will be dt upon dx. Dx I transferred here and 2 I have transferred onto the right hand side. So x dx will become 1 upon 2 into dt. Now 1 upon 2 I am keeping out, x dx became dt, so I am keeping here dt under root of, please note this power, there is no power on t, it is actually root t only. The same term I written once again over here to avoid any confusion. Okay, now under root of t, because x square minus 1, x square minus 1 I have taken as t and root sign will be applicable as it is. Okay, now under root of t can be written as t to the power 1 by 2. And t to the power 1 by 2, when we'll go at the place of numerator, the sign of the power will change. it will become minus 1 by 2. Now further, I applied the formula integration of x to the power n dx is equal to x to the power n plus 1 upon n plus 1, because here in place of n we are getting minus 1 by 2, in place of x we are getting t, and in place of dx we are getting dt. So apply the formula n plus 1 upon n plus 1. That will become 1 by 2, 1 by 2, and this 1 by 2 which is in the place of denominator will come at the place of numerator, means it will be reciprocal, becomes 2 upon 1. And here power 1 by 2 I am writing in the root, under root of over there, and value of t I am writing x square minus 1, plus here constant I am supposing c1, because I am finding the integration 1, so constant I am supposing here c1. Okay, so final value is coming here under root of x square minus 1 plus c1. Now similarly, let us find out the value of I2. Value of I2, say I2 is here, integration of dx upon x square minus 1. 1 I wrote as 1 square. And again this whole integration is in the form of integration of dx upon under root of x square minus a square. Okay, so under root of x square minus a square is equal to log mod of x plus under root of x square minus a square. Okay, in place of a I am writing 1 here. And now this will become the value of second integration. Both the integration values I kept here. This is the value of I1 and this will be the value of I2. Okay, now both the values I am keeping in the subtraction because sign is here. C2 will have the sign minus. So from C1 minus C2, again I am supposing a new constant here C. You can write down C1 minus C2 also, but the smaller way is to write down C1 minus C2 is again considered as a new constant will be C, and this will be the value of the given integration. Let us see the last question of this kind. Now last question we have I is equal to integration of x square dx upon under root of x to the power 6 plus a to the power 6. Okay, x to the power 6, remember the first question of today's, I wrote in the same manner x cube whole power 2, and same way I wrote here a cube whole power 2. You will say you are supposing x cube as t over here, then why you are writing a cube whole power 2? Because I need the question in the form whose constant term and the variable should have the power 2 only. So here what I will do, the power 2 will be utilized in the formula and a cube I will take as a furthermore. Okay, so now let us take first x cube is equal to t. X cube differentiation 3x square, power will come down and from the power 1 will be subtracted, and derivative of t will be dt upon dx. Shuffling the terms will give you this value. Now this value I am keeping 1 upon 3, I am keeping it out. Integration of dt upon c x cube I am keeping as t, and power 2 will be as it is. Same way this term I am writing same as it is. Remember my a will be here a cube whole. Okay, so now let us apply the formula. Formula I have written down here, integration dx upon under root of x square plus a square. Formula is written over there. Let's see how we put the value. In place of x I kept here t. Again in place of x I kept here t, but here t x square, so it is coming t square. And in place of a, I told you earlier, in place of a I am keeping a cube. Power 2 will be coming as it is. Now at the last we shall keep the value of t, that is x cube plus, and again x cube is coming in place of t. Further 3 and 2 will multiply, it will become 6, and same way here also 3 and 2 you can multiply, it will become 6 also. Okay, so this will be your total answer. Now I will write down which questions today you have to try. You have to try similar set of the questions which are given in the assignment. The assignment is also I am going to upload on the WhatsApp, so you can see that assignment and try the similar kind of question. This method we have taken special formulas from the integration. Now tomorrow I will upload the video for completing the square method. Okay, thank you.